Okay, this is a video demonstration for how to do the cross multiplying in 11.8, problems 6 through 11 and 14 through 19. Okay, so if we start with problem number 6, this one's very simple. 3 over x equals x over 12. All right, so we're just going to solve by cross multiplying, which is the butterfly or a proportion. And we put the 3 and the 12 together, the x and the x together, and we get x squared equals 3 times 12, 36. Then we're going to take the square root of each side. Now remember, because we are drawing the square root, when we give the answer, we have to give it as the plus or minus answer. So since x squared equals 36, x can equal positive or negative 6, and that is our answer to problem number 6. For problem number 7, we have negative 4x over x plus 1 equals 2 over x minus 2. We will do a butterfly again. And we'll make sure that we recognize that everything on the numerator has to have parentheses around it. Everything on the denominator has to have parentheses around it, okay? So make sure we understand that that's how the butterfly is going to need to be applied. Grouping those things together like this. Okay, that's kind of a sad butterfly. Oh, that looks like a hot dog. Okay. All right, so we're going to put 2 and the x plus 1 together equals, and then we'll have the negative 4x and the x minus 2 together. To be extra safe, we can just put parentheses around each numerator and denominator. You don't necessarily need it if you don't have addition or subtraction. We're going to have here, we're going to distribute. So we're going to distribute the 2. Here we'll have 2x plus 2 equals, and then we'll distribute here. Negative 4x times x is negative 4x squared. And then we have negative 4x times negative 2, which will become positive 8x. Okay, so at this point, the problem is going to become more steps. So it didn't give us a nice little, oh, x squared equals 36 like we had in the previous problem. We now have very complicated and really complicated to work with. So the first thing we want to do once we have finished cross multiplying is to now look for ways to solve for x. And the first thing you do is you combine like terms. You also try to get everything over onto one side if it looks like you're going to be dealing with a quadratic or something where the variable is squared. Well, I already see it's x squared, which tells me I might not be able to solve it because I see that there's an x term and an x squared term. That tells me that this might be a problem that needs to be solved by factoring, in which case I will want everything on one side and 0 on the other. If it was something where it was just x squared on one side and a number on the other, again, like the previous problem, I'd handle it differently. So you have to decide, once you get to this point, you have to decide, well, what pieces do you have? What final strategy are you going to have to use to solve for x? So I am going to pull everything over to the right side. I'm going to subtract 2x from here and here, and I'm going to subtract 2. So I will have 0 equals negative 4x squared, and then we have 8x minus 2x plus 6x minus 2. Okay, now I'm going to say, all right, yep, this looks like a classic trinomial, so let me factor it now. Now, there is something I can divide out of all 3 terms, so let's do that first. What can I divide out of all 3 terms? I can divide out, looks like I could take a 2. Oh, a negative 2. So let's put negative 2 on the outside, and we will then have positive 2x squared plus 3x plus, oops, no, my bad. If I divide out negative 2, I'm going to get negative 3x here. And then positive 1. Okay, that's a little bit easier to factor. So now I got to factor this guy. Okay, equals 0. Alrighty, so I want to factor the 2x squared minus 3x plus 1. I'm going to need 2 and 1 as the factors of the first guy, 1 and 1 as the factors of the second guy. Let's hope that works out to make a negative 3 in the middle. To make it be a negative 3 in the middle, I need to make this be negative 1 here, negative 1 here. Put my x's in and check to make sure that really is going to make the original problem. So I would say, okay, I'd have minus 1x as my middle term and minus 2x. Oh, guess what? That really will make negative 3x. Okay, then that is the correct way to factor this problem. The negative 2 on the outside doesn't really do anything. My solutions of x would be found from, let me change colors, would be found from here and here. So 2x minus 1 equals 0, and x minus 1 equals 0. So I'll continue solving until I have values of x. Here I'm going to add 1 to each side. 2x equals 0. Well, oh, sorry, not 0. I had a 1, sorry, I dropped him. Well, now I'll just divide by 2. And I will get x equals 1/2. Okay, x equals 1/2. That's one of my answers. The other answer is going to be plus 1, x equals 1. Okay, so my answers are x equals 1 and 1/2. Okay, with something like problem 8 and problem 11, the additional strategy I'm going to have to add, so for problems 8 and 11, is I'm going to have to use least common denominators before I can even cross multiply. You can only cross multiply when it looks like this. Something, so it can be a number or a polynomial, so we'll do like this. You have something over something equals something over something. You can only cross multiply when you have one fraction being equal to a second fraction. Okay, so you have to use cross multiplication only when there's two fractions. In problem number 8, so if we scroll down, I write problem number 8 down. Problem number 8 is x over 6 plus 15 over x equals 5 over 6. The problem with this, look, I have a fraction on the right side. Yay, so here's a fraction here. I have two fractions here. I cannot solve this problem until I have made these guys into one fraction. Now, this one's pretty easy because I just multiply the other guy's denominator by everything. Right, so my new denominator is 6x. And my fractions top is x squared plus 15 times 6, 30 times 390. So that equals 5 over 6. Okay, and I take this guy and now I'm going to change colors. Now I cross multiply. And this is going to be a very big problem. There's going to be some big numbers that we're making here. So for one like this, you definitely will want to use your calculator so that you're not just spending all of your time, writing out the multiplication and things like that. Wrap this one up really quickly. So when we do then this problem, we're going to put, oh my God. We're going to put the 6 here. We're going to have 6 times x squared plus 90 equals 5 times 6x. You see where all those where all those pieces came from? Let me change colors. The 6x went here. The 5 went here. This 6 went here. And this went here. It's kind of a mess. Something that you can notice, though, is kind of fun. We could actually divide 6 off of both sides, and that just makes the problem smaller overall. So now we have x squared plus 90 equals 5 times x. That's all that's left. And then we subtract 5x because we should be thinking, oh, this is a trinomial. Subtract 5x. X squared minus 5x plus 90. When you see something like this, you should be thinking, I don't think I can factor this one. So it turns out this one cannot be factored. Here's a clue that it can't be factored. You could use the discriminant test, or you could just notice that, what are the factors of 90? Can you think of factors of 90 that are 5 units apart? The factors of 90, there aren't actually all that many, or the factor pairs that make up 90. So you have 1 times 90, 2 times 45, 3 times 30, and notice that none of these are 5 units apart, and we're trying to get -5. None of these guys are 5 units apart. 1 times 90, 2 times 45, 3 times 30. You can use your calculator for a few more, but if you just go through the factors of 90 really quickly, so 90 divided by 4 is 22.5, so that's not going to help us. So we can't use 4, but if we have 5 and 18, that's as close, I believe that's as close as the factors get, and 18 minus 5 is 13 units apart. Because the next one that we have is, well, no, sorry, it's a little bit closer. I forgot about 6 and 15. But again, 6 and 15, that's still not 5 units apart. 6 and 15 are 9 units apart. And then I don't think we can keep going. Let's see, 90 divided by 7 doesn't work. 90 divided by 8 isn't a whole number. Divided by 9, that's the same distance that we saw with 6 and 10. These are 9 units apart. 90 divided by 10 is 9. Oh, look, we're now at the point where our factors repeat. Okay, so we never got somewhere that was 5 units apart. So we can't factor this one. So this one we would just say it has no solution. Okay, in general, when you're solving problems like these and you're trying to use the butterfly, first you need to get everything on one side to be a single fraction. You have to use common denominators for this. If you, on the other side, like say on this side right now, it already came as one fraction. If it was 2 fractions, use least common denominators there. You'll have to do that on problem problem 11. You just have to fix the left side. The right side is already 1 fraction. Let's see, if you were to do, let me see if there's one that has, there doesn't seem to be one that has 2 fractions on both sides, but in the section 26 through 38, wherever you have 2 fractions on one side, you have to make them into 1 fraction. So number 26, you need to use common denominators to get the left fractions into 1 fraction. Number 38 is going to be a mess. However, that is the skills that you used in lesson that had adding and subtracting rational expressions. Which lesson was that? That was 11.5, 11.6, adding and subtracting rational expressions. You have to use all of that skill in these problems to get to a point that you can cross multiply.